So good morning everyone. So today we are going to discuss another topic of unit 1, that is column chromatography. So column chromatography also one of separation technique. So in this column chromatography we use a column. Uh, in previously we have used thin layer chromatography and then paper chromatography. In those we have used a plane plane surface or plane medium which is used to support our stationary phase. But here we are using a vertical column or vertical glass tube, so which supports our stationary phase. Okay, so that's why this chromatography technique is known as column chromatography. So column chromatography is one of most useful method for the separation and purification of both solids and liquid compounds. So here this is very widely used after paper chromatography. So paper chromatography is very simple and cheap, but whereas this column chromatography is very effective, sensitive. It is frequently used in the pharmaceuticals and our organic labs for purification and separation method. Okay, so this is column chromatography is a type of solid liquid technique in which stationary phase is a solid and mobile phase is a liquid. So previously we have discussed paper chromatography. In that paper chromatography, stationary phase is liquid and which one is supported on the solid paper. In TLC, the stationary phase is again solid. Again, that solid is supported or placed on uh, thin layer. Now, that is what we say glass slide or aluminum foil. So, but here we are using solid, and this solid will be supported by a column. Okay. Next, when we have a stationary phase as a solid, so then the principle is adsorption principle. Okay, working principle, or you can say working mechanism. So that depends on the adsorption method. Okay, so what is adsorption? Adsorption is nothing but the concentration of a solute or adsorbate molecules on the surface of adsorbent. So that is known as adsorption. What is adsorption? Concentration of adsorbate molecules on the surface of adsorbent. So here in this technique, adsorbent is our solid and adsorbate are our analytes or sample. Okay. So here see mixture of component dissolved in the mobile phase is introduced into the column and components moves depending on their relative affinities. So here the working principle, how this column chromatography runs or works. So first what we do, so first we take a mixture of components, so which are to be separated. So that components will be dissolved in our mobile phase or solvent frame. So this then we get a solution, and that solution is introduced on the column. And then what happens when the solution of mixture is introduced on the column? Then what happens? So due to gravitational force, these components uh, diffuse through our stationary phase. Meanwhile, or during that, what happens? These components have different affinities toward the stationary phase. That is our solid. So that is our adsorbent. Adsorbent. So here the mixture is adsorbate. So the adsorbate are the component which has more affinity towards the adsorbent, that will held strongly, and the another are remaining components which have less affinity towards the stationary phase or solvent solid phase will diffuse or travel some distance. Okay, so this is C. So this is our column. This is our column. Okay, this is our column. Just like our burette, we are using. You are also allowed to use a burette as a column also. So frequently we use burette. So this is one type of column. And the adsorption column chromatography, the adsorbent is packed in a glass column. So this is the column, glass column. In that glass column, what we do first, we introduce a cotton or glass wool. So first we place a cotton or glass wool at here. So after that only we introduce the column. stationary phase. So meanwhile, what happens sometimes the cotton after column, what we do, we add a little amount of sand also. Okay, sand also. Okay, this is stopcock. So when we open the stopcock, what happens? The whatever the components introduced on the surface, what happened? They slowly diffuses and coming out. Okay, so it will take some time. So first what we do, first we take a clean burette or column. So at the bottom of that column or above the stopcock, what we do, we place a cotton or glass wool. So what is the purpose of introducing or placing cotton? To prevent the escape of silica gel. So here the silica gel is our stationary phase. Okay. So to remain our stationary phase, we introduced what, or we placed what, cotton or glass. Followed by what we do, we take or we fill this column with silica gel. After that what we do, we fill the column, and at the surface of the column just we add a little amount of sand, little amount of sand. Sometimes we don't add sand, but it is good to add sand. So why? To protect the silica gel surface. So the sand will protect the silica gel surface. What happens sometimes is our stationary phase may have reactive components, and or it may undergo oxidation with air, or it may react with carbon dioxide. Okay, so to prevent this type of unwanted things, what we need to do, we need to protect our surface of the column. So how we can protect the surface of the stationary phase or silica gel? By introducing little amount of sand. Okay, so this is about the column, and this is column, glass column, and a solvent, the mobile phase. When we introduce the sample or mixture, then what happens? The sample mixture will diffuses or partition uh, through this column. Meanwhile, what happens? The components will be absorbed on the surface of our silica gel or stationary. So these components in previous slide I shown you. So the component moves depend on their relative affinities. So that means a component which has more strong affinity toward the adsorbent, that will be adsorbed strongly and that will be remain at top. Okay. So that will be remain top here. So this component is adsorbed very strongly, and these components are adsorbed relatively less strongly. So depending on their relative affinities, the components travel or move some distance. Okay. And then what happens? So after that, we introduce the solvent, and that solvent is also known as mobile phase, and it is also called as eluent. So eluent means what? So it will take out the components. And next, so what steps involved in this column chromatography? So how we can prepare a column chromatography technique? So there is other required. So column characteristic selection. So selection of column, selection of stationary phase, selection of mobile phase, preparation of column, introduction of sample on the surface of stationary phase, development of column, detection of compound, recovery of compound. So these steps are involved in column chromatography. So first one is what? Selection of suitable column. So column is glass tube. So the stationary phase adsorbent mixture weight ratio. So this material, the good quality nature glass, plastic, or nylon to be used. So this is about the selection of the column. So glass tube, and this is about the adsorbent. So adsorbent is nothing but stationary phase, or here the adsorbent mixture. So the ratio should be when we are using stationary phase or adsorbent. So our adsorbent mixture ratio, when we are using more than two adsorbents, for example, silica gel, frequently we use silica gel sand. So here the silica gel should be in 30 proportions and sand should be in 1 proportion when we are using mixture of adsorbents. Okay, adsorbate. Sorry. adsorbent. Sorry, this is adsorbent. Adsorbent means the stationary phase. Adsorbate means the sample solution. So adsorbate and adsorbent proportion should be 30:1. Sorry. Adsorbent should be in 30 proportions, and adsorbate, that means the sample mixture to be separated should be in 1 proportion. So this is adsorbent and adsorbate proportion. Next, the column length and the diameter ratio should be like this. So our column length should be 30 to 10 to 15 centimeters or millimeters, and then width diameter should be 1. Okay. And next, multi-component system is present. Long column to be used. Multi-component means if we need to separate more components, then we require a long column. So long column means at that time we may adapt or we may go with this one. Next, component with similar affinities of our adsorbent are present again. So means components with similar affinities means, see, the adsorbent is polar in nature and our components are polar in nature. So at that time also we require long column. And component with different affinities for adsorbent. So that means if our adsorbent is polar in nature and the mixture is in non-polar, at that time we can use short column. Okay, short column means 10 to 50. The length should be 10 to 50 millimeters or centimeters, whatever. So the selection of the column depends on the nature of adsorbate and adsorbate. Next one, second one is stationary phase, selection of stationary phase. So here see our stationary phase used in a column is adsorption, are also known as adsorbent. Adsorbent. So here adsorbent, frequently we are using two types of adsorbents or stationary phase. One is the silica, second one is aluminum. Okay, so we have different types of silica and different types of alumina. So depending on the pore size. So these are the particles, the granules, or we have powder silica gel or powder alumina also. So they should be insoluble in solvent or mobile phase. The first thing is our solid phase should be insoluble with our mobile phase. So that means the nature of mobile phase and the nature of adsorbent or stationary phase should be opposite. So that means, yeah, we know that in second year we have studied in the solvents dissolve like dissolve means a polar solvent dissolve a polar component dissolves in polar solvent and non-polar component dissolves in non-polar solvent. So same phenomena here we should apply. So the adsorbent, that means stationary phase and mobile phase, both should be insoluble. So that means if we are selected stationary phase as polar in nature, then we should go with non-polar mobile phase and vice versa. And chemically inert. Chemically inert means our stationary phase should not have any reactivity towards our components as well as mobile phase. So that means our chemical phase should be chemically should be inert. The stationary phase should not undergo any chemical reactions with our components as well as mobile phase, and it should be colorless. Our stationary phase should be colorless. Why? Because if it is color, then it is not possible to visualize this type of bands. So chromatography name itself indicates that name is given because of chromo. Chromo means color. Graphy means different bands. Writing. So depending on, so this is one color, this is another color, like that. So that's why to visualize the colors of the components, our stationary phase should be colorless and should have reproducible property from batch to batch. So that means again we can reusable. That is, the particle should have uniform size distribution and have spherical. So it is very important, and the particle size of our stationary phase should be uniform in nature. So that means all particles present in our of our silica gel or alumina should be in same size and should be spherical. Should be spherical means గుండ్రంగా ఉండాలి. అంతరి size ఒకటే ఉండాలి. And the what we said, uh, desired size of our nanoparticle should be 60 to 200 microns. So the particle size of stationary phase should be lies in between these two. So this is about the properties of our stationary phase. And then come to some more properties. And the most commonly used chromatographic adsorbent is silica and silica acid or silica gel. So here again we have different natures of silica. Stationary phase, some stationary phase are acidic in nature, some stationary phase are basic in nature, some stationary phases are amphiteric in nature, some stationary phases are neutral in nature. Here also, if you use silica, the silica may be in neutral, it may be acid, or it may be a gel. So that means silica powder, we may have silica powder, salicylic acid, or silica gel. So which has the particle size like this. So these silica, these three stationary phase particle size uh, is lies between our desired size. So our desired size is 60 to 200 microns. And next, they absorb polar and unsaturated substances by the formation of a hydrogen bond with a hydroxy group on the silicon atom. So here, see, here adsorption takes place between the adsorbent. So your adsorbent is our stationary phase and adsorbate are our components mixture. So here what happens? They absorb polar and unsaturated substances. So that means if our mixture contains a polar component or unsaturated components, those two can be adsorbed by adsorbent through hydrogen bonds. Okay. And this is the type of mesh. Mesh means జల్లెడ అంటాం మనం జల్లెడ ఆధారంగా ఈ పౌడర్ ని మనం జల్లెడ పడతాం. So these meshes are useful to select or separate or to get this size of silica gel particles or stationary phase particles. And next one is adsorbent used in column chromatography. So generally we use different types of adsorbents. Here see based on their nature, we can classify the adsorbent: weak acidic activity, weak activity, medium activity, strong activity. So weak activity means almost all they may have what we say neutral in nature, so are slightly basic in nature. So sucrose, starch, insulin, talcum powder, or sodium carbonate, all these are weak activity. Weak activity means they show less affinity towards the stationary polar solvents. And medium activity means say calcium carbonate, calcium phosphate, these are. And strong activity means activated magnesium silicate. Activated means what? Activation అంటే ఏంటి ప్రీహీటింగ్ చేయటం. యాక్టివేషన్ మీన్స్ ప్రీ హీట్ చేయటం. యాక్టివేటెడ్ చార్కోల్ అంటే మన కోల్ ఉంటుంది, కోల్ని తీసుకొని మళ్ళీ దాన్ని హీట్ చేస్తాం. సో దాన్ని యాక్టివేటెడ్ అంటే. సో ఇక్కడ చూడండి యాక్టివేటెడ్ చార్కోల్, యాక్టివేటెడ్ సిల్క్. సో దిస్ ఇస్ అబౌట్ ది అబ్జర్వర్ stationary phase. And next mobile phase. So mobile phase etla. So just now in previous slide I told you we have this is they should be insoluble in solvent or mobile phase. So our stationary phase should be insoluble in our mobile phase. And moreover, chemically inert. Chemically inert means the nature of the stationary phase as well as mobile phase should be opposite. So if we are using polar stationary phase means that means we need to use non-polar mobile phase. Okay. So here see. Okay. So mobile phase acts as a solvent to introduce the mixture into the column. As a developer to develop the zones for separation and eluent to remove and pure components out of the column. అంటే ఏంటిది? So mobile phase ఏం చేస్తుంది? Mobile phase facilitates the proper separation of components on the stationary phase, and also it will take out eluent means taking out the components one after one. Next, the strain has arranged the solvents in order of the eluting power. A grouping of solvents in order to chromatography strength polar index is known as allotropic series. So this is allotropic series. So in this allotropic series, the series is constructed by strain, and in this series he constructed how he placed different solvents by increasing their polarity. Okay. So this is increasing eluting power. Eluting power means, so see, if you, petroleum ether, non-polar, ether, hexane, these are non-polar in nature. Next, chloroform, slightly polar, ether, non-polar, ethyl acetate, slightly polar, acetone, polar, alcohol, more polar, water, more polar, pyridine, more polar than water, organic acids, for example, acetic acid, formic acid, benzoic acid, these are, and next inorganic acid, hydrochloric acid, these are all these. So he constructed this series by placing these solvents according to their polarity, or we can also say in another words as increasing eluting power. Okay, so depending on this, we can select or we can go with either one solvent or mixture of solvents. Okay. Next one, preparation of column. So how we can prepare the column? So this is our column. So this is our column. How we can prepare this column? This process is also known as packing. The preparation of column is also known as packing. So preparation or packing of the column. So packing of the column, or we can prepare column by two methods. That is, one is wet method and second one is dry. In wet method, what we do, we use slurry. So again, already we have discussed about slurry in the PLC. What is slurry? Slurry is nothing but a paste. Paste. Okay. So here also, the first what we do, how we can prepare a slurry. Say the adsorbent is suspended. 1 minute. Obviously, adsorbent is suspended in the mobile phase and stirred very well to remove all the air bubbles. The resulted slurry is then poured into the column. So first we are taking a beaker, a small beaker. In that small beaker, what we are doing, we are adding little amount of mobile phase, and to that we are adding our adsorbent, and we are stirring in a such a way to avoid formation of bubbles, air bubbles. If any bubbles are present, then what happens? It may develop cracks. It may develop a cracks. Thereby, we cannot get proper separation of components. So to avoid that, so we need to be, we should be very careful to remove about the air bubbles. Once the air bubbles are all removed, then what we get? We get a slurry. And then at the bottom of the portion of the column, a piece of glass wool or cotton or Wattman filter paper or a disc must be added before the application of the slurry. So that means, see, so if we add the slurry, what happens? It may directly diffusers are coming out through this plug. So above this plug, what we need to do, we need to, here we need to place some cotton or Wattman filter paper. After that only we need to introduce slurry. After slurry application, the column must be allowed to settle overnight. So after introducing the slurry into the column, we need to keep aside for overnight, and this is the ideal method for column packing. So wet column packing ki suitable method. So first ఏం చేయాలి, మనం బ్యూరెట్ తీసుకోవాలి. క్లీన్ బ్యూరెట్ ఇన్సైడ్ అనేది క్లీన్ గా ఉండాలి. దాని తర్వాత ఏం చేస్తున్నాం, మనం స్లర్రీని తయారు చేసుకుంటున్నాం. స్లర్రీని ఎట్లా తయారు చేస్తున్నాం, ఒక బీకర్లో కొంత మొబైల్ ఫేస్ తీసుకొని దాంట్లో మనం అడ్జార్బెంట్ ని యాడ్ చేసి బాగా స్టిర్ చేయాలి. ఎట్లా స్టిర్ చేయాలి అంటే, ఎంతవరకు స్టిర్ చేయాలి అంటే యూనిఫామ్ అంటే మనకు ఎయిర్ బబుల్స్, గాలి బుడగలు లేకుండా ఉండాలి. దీని తర్వాత ఏం చేస్తామో, స్లర్రీని మనం బ్యూరెట్లోకి తీసుకుంటాం. సో బ్యూరెట్లోకి అంటే కాలంలోకి తీసుకునే ముందు కాలం కింది భాగంలో ఏం చేయాలి, కొంచెం గ్లాస్ వూల్ లేదా మనం కాటన్ లేదా పేపర్ ఉంచిన తర్వాత స్లర్రీని అప్లై చేయాలి. స్లర్రీని అప్లై చేసేటప్పుడు కూడా నెమ్మదిగా ఆ ట్యూబ్ బ్యూరెట్ని ట్యాప్ చేయాలి. ఇట్లా ఒక ఏళ్ళతో ఇట్లా నెమ్మదిగా కొడితే ఏమవుతుంది, స్లర్రీ మొత్తం యూనిఫామ్గా కిందకి దిగుతుంది. దిగినాక ఏమవుతుంది, దాన్ని మనం ఒక రాత్రి మొత్తం కట్లకుండా పెట్టిన అప్పుడు మనకు స్టేషనరీ ఫేజ్ అది కాలం అనేది ప్రిపేర్ అవుతుంది. సో ఇది ఏ మెథడ్, డ్రై మెథడ్, సారీ వెట్ మెథడ్. నెక్స్ట్ డ్రై మెథడ్. సో డ్రై మెథడ్లో ఏం చేస్తున్నాం, ఇన్ దిస్ డ్రై మెథడ్ ది అడ్జార్బెంట్ ఈస్ poured ఇన్ కాలం డైరెక్ట్లీ. సో ఇది కాలం అనుకోండి. ఈ కాలంలో ఏం చేస్తున్నాం, ఇది అడ్జార్బెంట్ ని నేరుగా తీసుకుంటున్నాం డైరెక్ట్. ఇంతకుముందు ఏం చేసినాం, అడ్జార్బెంట్ ని స్లరీగా మార్చినాం. ఇప్పుడు ఏం చేస్తున్నాం, వీఆర్ నాట్ ప్రిపేరింగ్ స్లరీ, డైరెక్ట్లీ వీఆర్ pouring our adsorbent into the column, and then vibrate it టు గెట్ రిడ్ ఆఫ్ ఎయిర్ బబుల్స్. సో ఇప్పుడు ఇట్లా ఇంట్రడ్యూస్ చేసిన తర్వాత మళ్ళీ దీంట్లో మనకు ఖాళీ జాగాలు లేదా ఎయిర్ బబుల్స్ రావచ్చు. మళ్ళీ దాన్ని ఏం చేస్తున్నాం, టు అవాయిడ్ ది ఫార్మేషన్ ఆఫ్ ఎయిర్ బబుల్, వైబ్రేషన్ అంటే వీ కెన్ వైబ్రేట్ బై మీన్స్ ఆఫ్ ట్యాపింగ్ అంటే ఇట్లా నెమ్మదిగా కుట్టాలి, ఏల్తో ఇట్లా నెమ్మదిగా కుడితే దాన్ని ట్యాపింగ్ అంటాం. సో అట్లా వైబ్రేట్ చేసినప్పుడు ఏమవుతుంది, మధ్యలో ఏమన్నా ఎయిర్ బబుల్స్ ఏమన్నా లేదా గ్యాప్స్ ఏమన్నా ఉంటే అవి ఫిల్ అయిపోతాయి. దాని తర్వాత ఏం చేస్తున్నాం, దెన్ మొబైల్ ఫేజ్ ఈజ్ పాస్డ్ త్రూ ది అడ్జార్బెంట్. సో దాని తర్వాత మనం మొబైల్ ఫేజ్ ని పాస్ చేస్తాం. అంటే ఇట్లా చేసిన తర్వాత దీని మీద నెమ్మదిగా మొబైల్ ఫేజ్ ని పెడతాం. ఇంతకుముందు లెక్కనే ఈడ కూడా ఏం చేయాలి, కింద క్లాస్ ఫుల్ ని పెట్టాలి. క్లాస్ ఫుల్ ని పెట్టినాకనే ఇది మనం స్టేషనరీ ఫేజ్ ని ట్రాన్స్ఫర్ చేయాలి. చేసినాక దీనిపైన ఏం చేస్తాం, మొబైల్ ఫేజ్ ని ఇంట్రడ్యూస్ చేస్తాం. సో ది the demerit with this method is that the air bubbles are entrapped between the solvent and the stationary phase. సో ఇప్పుడు మన మొబైల్ ఫేజ్ ని ఇంట్రడ్యూస్ చేసినాక ఏమవుతుంది, దీంట్లో ఒక లోపం ఏమవుతుంది అంటే ఆ మొబైల్ ఫేజ్ స్టేషనరీ ఫేజ్ కి మధ్య ఏమవుతాయి, ఎయిర్ బబుల్స్ వస్తాయి. దిస్ మెథడ్ కెనాట్ బి అప్లైడ్ ఇన్ జెల్ క్రోమటోగ్రఫీ. సో జెల్ క్రోమటోగ్రఫీలో దీన్ని వాడకూడదు. సో ఈ విధంగా మనం ఏం చేస్తాం, ప్యాకింగ్ చేస్తాం. సో ప్యాకింగ్ చేసిన తర్వాత నెక్స్ట్ కాలం క్రోమటోగ్రఫీ, అసలు ఎట్లా శాంపుల్ ని ఎట్లా ఇంట్రడ్యూస్ చేస్తాం. సో హౌ వీ కెన్ ఇంట్రడ్యూస్ ది శాంపుల్. సో ది ఫస్ట్ మెథడ్ ఇస్ selection of column, second one is selection of stationary phase, third one is selection of mobile phase, fourth one is preparation of the column. Again, preparation of the column again can be done by two methods. One is dry method and second one is wet method. After that preparation of column, next one is what, introducing the sample. So how we can introduce this sample on column. So the sample, which is usually a mixture of components, is dissolved in minimum quantity of mobile phase. So direct ga manaku solid components ante if our mixture is a solid, then we cannot introduce directly. So we need to be dissolve that components in our mobile phase. Mobile phase lone mana solvents ni dissolve chestam. Dissolve చేసిన తర్వాత ఏమొస్తుంది, మనకు సొల్యూషన్ వస్తుంది. ఆ సొల్యూషన్ is introduced. The entire sample is introduced into the column at once and get absorbed on the top portion of the column. సో సొల్యూషన్ మొత్తాన్ని ఏం చేస్తున్నాం, ఈ పైన తయారు చేసిన సొల్యూషన్ మొత్తాన్ని ఒక్కసారిగా నెమ్మదిగా అంటే ఎట్ వన్స్ స్లోలీ ఏం చేయాలి, మొత్తం దీని మీద ఇంట్రడ్యూస్ చేయాలి, అంటే ట్రాన్స్ఫర్ చేయాలి. ఎవరి మీద, సర్ఫేస్ ఆఫ్ ది కాలం. సో అట్లా కాలం మీద ట్రాన్స్ఫర్ చేసినప్పుడు ఏమవుతుంది, ఈ కాంపోనెంట్స్ ఏమవుతాయి, ఈ స్టేషనరీ ఫేజ్ తో అది శోషించబడతాయి. And from this zone the individual samples can be separated by the process of elution. So ఇప్పుడు మనం ఇంట్రడ్యూస్ చేసిన తర్వాత కొంతసేపటికి ఏమవుతుంది, మన మొబైల్ ఫేజ్ ని ఇంకా తీసుకురాలి. సో వితౌట్ ఇంట్రడ్యూసింగ్ ది మొబైల్ ఫేజ్, వన్స్ వి ఇంట్రడ్యూస్ ది sample solution onto the stationary phase, what happens, the component which has the more affinity that will be absorbed strongly by adsorbent, and the component which has less affinity toward the adsorbent, that will diffuses or travel some distance. So this is first step. After this, what happens, in second step we introduce the mobile phase. So this mobile phase facilitates the easy separation or faster separation of this mobile phase. So this yellow color is less affinity toward the stationary phase, and the component which has less affinity toward the stationary phase, obviously that will have more affinity toward the mobile phase. So at that time, what happens with the mobile phase, this yellow colored component travel more distance. This is first step after introducing the mobile phase. And after some time, what happens, so first what we collect mobile phase. After that, slowly we collect this yellow colored substance, and after 1 hour or after some time we also collect the stationary phase. So this is known as the development of chromatogram, so or separation of chromatogram. Okay. And next, column chromatography, development technique. So that is elution. Development technique is nothing but this one. This technique is known as development technique, or it is also known as elution. By elution technique, the individual components are separated out from the column. The two techniques are used. So here the elution are again two techniques: isocratic elution technique and gradient elution technique. In isocratic elution technique, what we do, in this elution technique, same solvent composition or solvent of same polarity is through or used throughout this separation process. So that means, so here we use only one type of solvent. If we are using one type of solvent as mobile phase, that technique is known as isocritic elution technique, for example, chloroform. And next, in gradient elution technique is what the solvents of gradually increasing polarity or increasing elution strength are used during this process. Example, initially benzene, then chloroform, so one after another. So here first we introduce benzene. After some time we use uh, the solvent which has more eluting power than benzene, that is chloroform. After that we use ethyl acetate, one after one. Okay. So this technique is known as gradient technique. And next, detection. So whatever the compound we received at the end during the elution. So here see, this is a yellow colored compound. This is compound is received or separated. After sometimes it will be separated. So see, after separation, what we do, detection of components. So how we can detect? If the compounds separated in the column chromatography produce or colored, the process of the separation can be simply by monitoring visually. So that means if our components are colored like this, if components are colored, then it is very easy to identify. If the compounds is to be isolated from the column chromatography are colorless. In the case, small fractions of eluent are collected sequentially and in labeled tubes. So that means if our components are colorless, then how we what we do? So first we take some quantity, small fractions of eluent. So the whatever eluent means the mobile phase coming with the mobile phase as well as it may contain components. సో స్మాల్ ఫ్రాక్షన్స్ అంటే కొద్ది కొద్దిగా ఏం చేస్తాం, వాటిని కలెక్ట్ చేసి ఆ పార్టికల్స్ని లేబుల్ చేస్తాం సీక్వెన్షియల్లీ అంటే వన్ ఆఫ్టర్ వన్. అండ్ దెన్ కాంపోజిషన్ ఆఫ్ ఈచ్ ఫ్రాక్షన్ ఈస్ అనలైజ్డ్ బై టిఎల్సి. సో అప్పుడు దాన్ని మళ్ళీ దేని మీద అనలైజ్ చేస్తాం, టిఎల్సి మీద అనలైజ్ చేస్తాం. నెక్స్ట్, so factors affecting on column chromatography and application limits we will discuss in next class. Okay, so thank you.